But yesterday I told Sebastian that there are a number of people here for which, all those talks they're purely incidental. This is the real reason. We're all dying to know what's going on. And so, on the schedule, we sort of put this as, Sebastian is going to give a talk and then we'll have a discussion. But basically what this, Sebastian, you can talk for as long as you want. And probably if I think it would be this is good to have discussion during the talk. If people want to ask questions,
we
can just keep going. So you've got like a wild card. No time limit. It's like the easiest session to chair. So, Sebastian.
Thanks, Jeremy. So yeah, I'm back here to tell you why we're still not finished with Lean 4. Was that informal enough? So yeah, as a quick reminder, what is Lean 4? And why are we rewriting Lean again? So, and the answer to that is really to finish the job that Lean 3 started. So starting with Lean 2, for those that still remember that, Lean 2 was a pretty simple world. Like you had tactics, you could write your theorems, prove your theorems using tactics, but they were all built in. There actually was this nice PDF with a few pages of just listing any tactic there is. And yeah, it was a really simple world. But yeah, you had no opportunity to add new tactics or even abstract over the existing ones. Yeah, so then Lean 3 came around and changed that quite a bit, as I think many of you know. And yeah, now you could actually write your own tactics and within Lean, within the Lean language, which now was became a programming language, or at least meta-programming language. And yeah, I think that worked out quite well. We're all surprised, and it's great to see what you're all doing with that system. But yeah, there still was this weird boundary between the system and the user. Like, yeah, you could write your own tactics in Lean, but there were also built-in tactics that were not written in Lean. And why is that? Well, for one, there's simply the performance difference between writing a tactic in C++ and writing it in Lean 3 using the Lean 3 interpreter. So that probably wouldn't work out for something like SIMP. And secondly, there simply were many APIs on the C++ side were not available even to the Lean language that would have been necessary to implement such tactics. Yeah, so, and really Lean, the tactic system in Lean 3 was still the best extension mechanism in it. You may know that there's also some sort of Parse extensibility in Lean 3, but it's really quite superficial and not easy to use. And there's simply too much hidden inside C++ code to use it in any meaningful way. And that's exactly where Lean 4 comes in and says, well, let's break down this boundary between the system and the user by simply rewriting the entire system, most of it, in Lean itself, make Lean a general purpose language so that there is no difference between a built-in tactic and something the user can write. Whatever Lean can ship with, you can also write yourself.
SIMP will be written in Lean?
Yes, yes, it should be. It is not yet, but I expect it to be. So much for the history. And of course, last time I showed the slide, someone immediately remarked that, oh yeah, Lean 4 has given us 2010X. So did we have a release in any 2019, I guess? Well, no, we did not. So really, I should say here, X is greater equals 0. Okay, so let's start with, so who is this we we're talking about, I'm talking about here anyway. So Vio, Leonardo Demura, and I, we're still at it. Vio is still working on basically all parts of the system really, and keeping them all in his head, keeping them all consistent. I'm also working on a bit of everything because frankly, it's just, yeah, every part is interesting. But I'm more focused on the front end and more specifically the new macro system. And then I guess I wrote a new interpreter at some point, so I'm responsible for that now, I suppose. But then we got some new company within the last year. So Daniel Salsom started at Microsoft Research last summer. And not only is he interested in using Lean 4 for his IMO Grand Challenge, which you may have heard about, but he also contributed code to Lean 4 already, being the new type class resolution system, which I'll also quickly talk about later. And just recently, Simon, who's also here. I'm not sure if he's here yet. Is he somewhere? All right. Well, I guess many of you know him. Yeah, he recently started an internship under Leo at MSR, and his internship project will be focused on the language server, which is this shiny new technology for integrating a compiler like Lean into your editor. Yeah, so that's the team as of now. So last year I showed this maybe helpful graph to give just a rough idea of where things were in the implementation. So last time we had we had a parser prototype that at least showed that our design was working in that respect. Yeah, we had already added a macro expander between the parser and the elaborator. So if macros don't say anything to you, just think of them as like supercharged syntax sugar, like, yeah, supercharged notations, which I'll also come to later. And all of this, these prototypes were powered by the compiler, which produced C code. And yeah, it already did quite a good job at it, but there were still a bit, it was not exactly finished yet. Just enough to keep the system going. So that was our state in last January. And then, yeah, we did spend quite a few months just improving on that initial design, like making the parser really robust. It's basically feature complete now. Actually figuring out our macro story. Yeah, I won't go into the hygiene thing today, but yeah, suffice to say that macros are now actually part of the elaborator, not a separate path, which means especially that you can use type information inside your super notations. Yeah, and the compiler is basically complete now, or at least we're, yeah, complete and fast, can always be faster. Yeah, and what I did not expect you to do is to actually re-implement some parts of it and add new parts of it in Lean, which is like the small green part inside the compiler. So now even our compiler is bootstrapped.
So, but you can also add new tasks or optimizations to the compiler from these?
That would be nice, but that API doesn't exist yet because, yeah, I mean, we don't need it yet for ourselves. Like, it's just the compiler, but yeah, would definitely be nice to have in the future. Yeah, so that was around June. And then Leo really started working on all the fundamentals to actually implement the new elaborator, which are, yeah, things like, which I call the module system here, which is the thing that imports your Lean files, yeah, when you actually write imports and saves them in the end of the file and sets up the environment and so on. And that is actually implemented most in Lean now, and it's actually working nicely, so that looks good. And there's only slight small part of C++ code there that's actually basically part of the runtime, which is the part that actually saves and stores and loads Lean objects to and from the disk. Because an Lean file in Lean 4 is just, yeah, stored Lean objects, actual Lean objects. Yeah, and then I did not expect Leo to actually re-implement the C++ type context, which is indeed free. It's the thing that does unification and type inference and so on. Yeah, to actually re-implement all of that in Lean itself. And it's now called the meta monad. And yeah, this is also looking quite nice already. And yeah, I did not expect that we, at this point already, would have a new type class resolution system contributed by Daniel. So yeah, these are just parts that are really necessary to implement a nice new elaborator. Yeah, at least if you want to have most of the system in Lean itself. Yeah, and going off from that, that was like not too long ago, something like December. We really started working on the new elaborator in the last month. And I think we did some good progress there. Like the term level part is already looking quite nicely. Basically does all the things Lean 3 does and much more. And yeah, now Leo is really working on implementing every single command this week. And yeah, we do have like 2 tactics currently in the tactic framework, which may not be quite sufficient for proving. Like there's intro and assumption, but at least it shows that that there is a tactic monad which is based on the meta monad, and it seems to work, and you can actually build tactics on top of that. But there are no tactic blocks, no syntax for that yet, and it's not being called from the elaborator yet. Yeah.
So the tactic framework would not call to compiler. When I write down a list of tactics in a term and I want to generate a proof, does it run over the interpreter or is it compiler or is it separate?
Yeah, that's a bit complicated. We try to avoid that by having basically a domain-specific language for tactics. When you just write a tactic block, not like a big meta program tactic, and that will actually use its custom interpreter to mostly avoid the compiler.
Okay.
Yeah.
So when I define a function, is it immediately compiled to C or is it?
It's immediately compiled to the intermediate representation, which can be used immediately by the interpreter. And if you give a special flag, then in the end, every definition of that file will be exported to C. And then you can compile that. Yeah. Yeah, so that's basically our status as of today. Yeah, I think it's looking pretty good. There's not that many completely empty things left. Like obviously after the elaborator, the tactic framework will be the next big thing to implement. Yeah, language server, as I said, Simon will soon start working on that. Yeah, and what else is there? Okay, yeah, there is still FFI, the foreign function interface down there. Yeah, we simply haven't cared about that yet because we don't need it to implement Lean itself. So we'll come at some later point.
I could start writing term mode proofs today.
So using the new frontend, yeah, you may find some bugs there. Using the old frontend, yeah, you may find some APIs missing. Like there's no set in the standard library right now because you don't need set to program.
Right, but I could define set.
Yeah, you could.
I could define bin set and is there a list?
Yeah, there is list. List is quite useful for programming. But we also now really make use of arrays like contiguous memory segments. Right. Yeah, so what I want to say, I think it's looking pretty good. And there are, of course, many smaller things missing that I haven't displayed here, like a new pretty printer and so on. But yeah, we'll come to that when the other parts are looking
Run the parser
nice.
backwards.
Yeah, exactly. Should be some Futamura projection or something. No. Was there? Yeah.
So everything that is in green, so it's implemented in lean.
Yes.
But does it mean that
Purely in
it
lean.
can be swapped? I mean, if some power user wants to replace, I don't know, part of how the elaborator is working, is it going to be possible or
So not out of the box, like you have to explicitly design that in some extension mechanism. But yeah, I mean, we really want to do that. Like that you can just swap out the elaborator for, say, I don't know, match or something and just do your own thing. Yeah. Or just, yeah, use the syntax of match and on top of that build a better, even better match and write your own elaborator for that. That will all be possible.
It all runs fine in Emacs right now.
Right now, yes. Since we don't have the language server at all, just works in Emacs for now.
So what exactly is the state of play with inductive types? I want to define an inductive type in a way like in free.
It's a good question.
Are they important for computer scientists?
Yes, they are. Yeah, you can definitely like construct the syntax tree of an inductive type and just pass that to the elaborator, and that will actually elaborate it as you had written it down. For that part, is actually not existing yet in the new elaborator. So I don't think inductors are supported right now yet. Yeah.
So I mean, in particular about lists. I mean, is this done in some ad hoc way, or is it defined like?
Oh yeah, it's exactly the same definition. Standard definition of constant nil. Yeah.
And it's written in lean, the definition of list, or is it?
Well, in the same way as in lean 3, like there's a lean code that says what a list is. Yeah. Like it's an inductive type.
Inductive type.
Yeah.
So you can make some inductive types.
Right, but so it's this is a bit complicated. It's in the standard library, which is still elaborated using the old front end. So yeah, we're not at the point yet where we can elaborate the whole standard library using the new front end. And at that point, yeah, it will also have to understand inductive types. Okay. Yeah, so just to give you an idea where we actually are. And yeah, for the remainder, I just wanted to pick some interesting parts I thought that we did in the last year that may be of your interest. So just to get it out of the way, if you look at Lean 4 code, you may find that it does not quite look like Lean 3 code in some particular parts. And we're not doing this primarily to annoy existing users. That is at most secondary. Yeah, it's just that we already knew that Lean 4 would not be fully backwards compatible to Lean 3. So we thought, yeah, why not, if it's not the same language anyway, why not try to make it as consistent and pleasant, well, at least to us, we think so, as possible. Yeah, so there were things like, yes, we did change the naming convention. Like we now use actual camel case for function names, and we think it just looks better. And we use casing to differentiate types from terms. And which means that, yeah, now you can actually have like a variable name that is of type name, and they don't shadow each other. And that's just really convenient. And yeah, to be honest, it's just closer to other languages, both programming and ITP languages, I think. So I could probably say, so this is not for discussion, I can already tell you that. This will never change again, maybe. But so what we didn't do so far is write many lemmas in it, because yeah, we are programming right now. So I think the lemma convention is still open, and I don't know what you think about that. We can discuss this later probably, but yeah, why not still use underscores there to really separate the semantic parts of a lemma name. And then you can actually like differentiate between what are the parts of the function name, like term name, and then the actual property between that. So I think this is actually more expressive than in the lean-free convention, if we want to do that. And then there are smaller parts like, yes, we've finally found a consistent pattern syntax after many, many years that we really like. So regardless of whether you're writing a def or a match, all of the patterns will now be separated by commas and then separated by from the right-hand side with this big arrow.
So then you separate the values, you match these comments?
Exactly, yeah. It's exactly the same syntax. Yeah.
Is there some end match at the end?
No, and is optional. Oh, I think it's not even optional. You can't write it. Yeah. 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 It just ends when there's no more equation. And actually, if you have nested matches and you dedent an equation, it knows that it has to be part of the outer match. Yeah.
White space is important.
Yes, in a few particular. Okay, so our philosophy for that was like we accept white space sensitivity when we think no user would ever write that in a different way and like haven't. Well, I wouldn't say that. Like we still okay. Can come get to the do. There's still a separator between like the do parts, for example. It's not Haskell where just every line is a statement basically. All right. I'm getting ahead of myself. So yeah, there are many other smaller syntactic changes. Like okay, we now prefer at least fun over this weird Greek letter for functions. And we also use the arrow there instead of, yeah, comma does look pretty weird, at least with fun here. And
Could we get a nice looking arrow instead of SPR?
yeah, I don't remember if it's in there right now, but yeah. I mean, there's basically the same arrow in Unicode, and you should definitely be able to use that. So that's just one symbol, one character. And yeah, like let uses now semicolon both inside and outside of do notation, which just makes it more consistent. And yes, do notation also uses a semicolon to separate statements instead of a comma. So yeah, you could say we removed some commas and added some commas, and that's mostly it. Yeah.
I think about using the maps to arrow in the mathematical.
So I like that idea of yours. Yeah, I think, as I said, you should define that yourself and try it out. And I don't know if everyone likes it, and we can take a look if we want to have it in the standard library. But yeah, I mean, that's the beauty of Lean 4. You can just define your own syntax if you really like it. Yeah, I'm not sure if Leo will like it. You'll have to ask him yourself. Okay, so let's get maybe to some more to some other parts that are not just cosmetics. So yes, we have a fast compiler. That's probably perhaps one of the biggest news in the last year, and we actually wrote a paper about it. So not only about the compiler, but actually about the reference counting implementation inside the compiler. So quite specific, and you really shouldn't have to worry about that as a user. You should not be interested in that paper. But yeah, the only interesting thing is the result that does this laser. Oh, nice. Yeah, so the result that, so to the right is like seconds, and that usually we are faster, Lean 4 is faster, at least in our benchmarks, than say OCaml in, yeah, basically all of our benchmarks, and usually quite a bit faster than even Haskell. So yeah, I think I can say we were quite surprised by that result. We did not expect it. We assumed that we should at least be competitive. And yeah, I think we can now say we are very competitive with other functional languages. And yeah, if you decide to write a tactic in Lean 4, you really should not suffer from the choice of language, at least performance-wise. Okay, what else is there? So yeah, the new type class resolution. You may have heard about it, a few things about it on Zulip. So it really tries to deal with at least two specific performance issues in the Lean-free implementation, which is diamonds, which we've heard about this week already, and cycles. So diamonds, the issue with diamonds is that if Lean-free does not manage to immediately find a proof, find an instance in a big hierarchy like the algebraic hierarchy, will actually try each single path inside the hierarchy. And yes, I mean, if you have a diamond, that means you have, or in the number of diamonds, you will have an exponential number of paths. And yes, that is a performance issue. And yeah, I guess even worse than exponential is non-termination. Like if you have a cycle in your instance graph, if you, if you get to an instance problem that you already had before, then Lean-free will simply cycle through that and never terminate. So yeah, that's not good either. So these may sound like quite simple problems. Like you may think, okay, can't we like cache successes and failures? Doesn't that just work? And well, in practice, it's a bit more complicated, of course, because yeah, the typeless system, there's unification and so on, and you can't just plug a cache in there and call it a day. That does not work. So maybe we don't have to reinvent the wheel here. So you may know from TPIL and so on that typeless resolution is described as a Prolog-like search, which I think is a quite funny sentence to mathematicians and other people that have never heard about Prolog before. But at least on the implementation side, it does tell us that there's a language Prolog, which maybe had the same problems in the past, and maybe also solved them in some way. And that's exactly what Daniel did. He adapted a known Prolog optimization called tabled resolution to the Lean typeless resolution. And yeah, that is our new typeless resolution system in Lean-4. And it does solve exactly these two issues. You can think of it as basically caching instances in exactly the smart way.
So, since the size of typeless problems is small, it means that if you have something like where you build up larger and larger instances, it will not.
Right. I think that's actually probably undecidable, right? Yeah, exactly. So so you're guaranteed termination as long as if the size of your typeless problems at least is bounded. Like as Johannes said, if they get bigger and bigger because you have like a typeless the instance that from A tries to find f of A and so on, then yeah, that will not terminate in the new system. Yeah. We're not using cuts yet. Yeah, but I don't know. Maybe that's a good idea. So yeah, I should say I don't really know much about this whole algorithm, and yeah, I don't want to explain it here anyway. Yeah, maybe you should ask Daniel that. Yeah. So unfortunately, he's not around here, but.
Is this written in C++?
This is all written in Lean.
In Lean?
Yeah.
And users, in theory, start modifying it if they don't like it?
Yeah, you can definitely try, like at least copy the whole code and try to modify it. I guess you'll have to somehow plug it into the elaborator. So yeah, maybe it's not completely straightforward, but yeah, I guess it should be possible at some point. You should try to enable that. Yeah.
What about ripping it out and replacing it with some well-known implementation of Prolog?
Unfortunately, yeah, many parts of this are too specific for Lean that you can't just plug in any Prolog implementation. Yeah. Oh, yeah, that may work. Right. You want to say anything else? Yeah. And we are actually now using discrimination trees to at least make a faster choice between type class candidates without doing too much unification. But that's like a smaller optimization, like sub-asymptotic, I think.
It also means that the if you go for your path search, if you get some messages for it, so you get much less, right? Because if you look at
I think so, yes. Yes, which I guess would be really convenient. Like, it won't show anymore the instances that make no sense at all. Yeah, yeah. I think that should work like that, yes. Yeah.
You will have access to more information when it doesn't work. Because currently, when typecast resolution fails, it's hard to.
We have access to a lot of information.
Yeah, we have access to a lot of information, but it's
Normally
really easy.
262,144 bytes.
Right. Yeah. Last year I talked a bit that we want to have at least definitely better structured log outputs, like trace outputs. Yeah, that's not there yet, but at least not in the interface. But yeah, you should at least should be much easier to follow the trace. Yeah, I'm not sure if there can be other improvements. I mean, yeah, we can talk about that if there's like just making better error messages. Maybe that is possible. I'm not sure.
And also, I think there was some discussion on Twitter about having a typecast resolution mechanism, including applying lemmas or coding tactics.
Right, right. We did discuss that at some point, but then discarded it again because it makes the whole system incredibly more complex. Yeah. So, so this is not something that's really, we have a prototype for that, but I think Leo's favorite approach is that there is a type class fact that takes any proposition, and then you just declare a local instance of that, of the type class using like tactics and so on. And then after that, in your text, you can actually make use of that instance. So it's like a hybrid approach. That's not like tactics are not directly used inside type class resolution, but at least you can mix them. Does that make sense? Okay, great. Yeah.
What about, so currently in Masspeed, we have all these tactics related to the instance cache in the have I and let I.
Right, right. Yeah, so I hope I'm not saying anything wrong, but that should just work. Like if you actually write a let in your tactic code that binds an instance, then this instance will automatically be available or have or something. Yes, yes, but still with actual working caching. Like I think before that it worked because the cache was completely broken, and now it should work even with the cache.
What about diamonds? We always have this problem about diamonds, which are equalities which aren't definitional. That problem's never going away.
I'm not sure I now
which are equal,
yeah,
but not definitional.
right. So
this causes problems.
okay, yeah, not sure. I don't remember at least any changes in that. Yeah. But yeah, I'm not the expert for this part of the system. Yeah, instead I'd really like to talk more about macros. So yeah, what is the state of the union? And here you thought it was just a punny title. So yeah, let's take a notation, maybe not completely trivial notation from Lean 3 and try it out, right? And yeah, I tried to do that. I'm not sure if it will work because this was implemented like yesterday. It was the wrong screen. All right. Is that big enough? It's just, all right, that's better. Okay, so what's going on here? Yeah, so this is a lead profile opened in Emacs. It's not using the language server, that doesn't exist yet. It's just like batch compiling the whole file and showing you the errors on the right-hand side. You know it's using the new frontend because it says new frontend right there. Like that's a command that just switches the remainder of the file to the new frontend, and then you're using the actual new elaborated new parser and so on. And yeah, I guess it's already complaining. All right, so this is almost the definition of lean-free. I did replace the backticks with double quotation symbols here because, to be frank, it was easier to implement, and I kind of like it. Like maybe Coq was right after all. Why make up a new syntax for just like adding new symbols? Anyways, so this is almost the definition in lean-free, and it seems to complain about this part, which is, yeah, this weird colon and then, I don't know, this notation extension. So I don't know, who thinks they've got this part in lean-free, what's going on with the scope keyword and so on? Is that clear to anyone here? All right, nobody. Okay, one, great, because I don't know either. Yeah. Okay, no, let's try to at least decipher this.
Just cut and paste another definition.
Yeah, exactly. That's how we do it. Yeah, yeah. All right. So roughly, what's going on here? This says at least to lean-free that if this big union symbol is followed by one or more binders, followed by a comma, then read a new term. This term is scoped by the previous binders, which means like it's abstracted over, it's introducing lambdas and so on. And then we take this abstracted term f and pass it to the actual union function, which is like a function that takes a set of sets and produces a set. And this, yeah, great. Yeah, and yeah, that's exactly what's written down here. Yeah. No problem. And yeah, after we pass it to union, this thing is bound to R, and that is actually the result that is returned here. At least that's how it's written in lean-free. And why is it written that way? Yeah, because name resolution is hard, and it's much harder if you don't even know what you're abstracting over here, like if it's a variable, a placeholder, and that's why we had this special notation to deal with that. So, okay, lean-4 doesn't seem to like that. So let's delete that. And I've just focused on a single binder for today. And let's just try it what we actually wanted to say. Like, as I said, we call the union function with the predicate R, whatever it's called R. I don't know. And abstracted over the binder B. And that actually works. So yeah, now I can say something like union of all x, so that x equals x, I guess. At least it seems we can use x on the right-hand side. And I can also give like a more specific type. Like these are all, these are both valid binders that I can use here. And so yeah, lean-4 is passing this thing, then it's inserting the x set unit as this b here, then inserting the x equals x as this thing here, and that actually works, and x is in scope, and yeah, you get exactly the result you wanted. Yeah. I don't know. Oh, of course I can't use x on the right-hand side then. Or what do you want to do? Okay, underscore empty set doesn't exist yet. False? False, right. That seems to work. It's a union over lambda sum a false. That's the right answer, right? Okay, yeah. Underscore is a valid binder, so that just works. So yeah, that's really the power macros give you, which now power the new notation keyword here. You can just plug in syntax trees, like syntax parts, into other syntax parts, which is exactly what we're doing on the right-hand side here. And it just does exactly the thing you want it to do. You don't have to worry about weird name binding anymore and weird forms for that. Yeah?
What do you do if you want to bind multiple variables in one unit?
Right. So I can't do this in notation right now. I'm not even sure notation should be able to do that. I'll talk about in a second what's about a system that's more powerful than notation. And so, yeah, you probably would want to use that for any less trivial, yeah, things. Yeah.
Say I want to have, I want to bind x by second term, and in my term I have x and x prime, like for word triplet or something. Would you possibly say like fun e and e prime or something? Or some functions, some notations where I can say here add e, but now modify it somehow.
Yeah, you should be able to do that. That's probably like out of the scope of notation. Like, yeah. So, yeah, so probably I should talk about that now. So notation here is actually a macro. It actually expands to other commands that actually implement it. And these commands actually then expand further on to actual meta programs. And on the meta program level, you can really do whatever you want to. Like there's always a level that solves your problem, basically. You just have to decide which one it is. Yeah, where was I? Right, yeah, so these two examples seem to work all right. So this one does not. All right, yeah, okay, so we're trying to do something slightly less trivial here, like we want to do the union over all x in a set. Unif is of course not that interesting, but just an example. And why does that not work? Well, if we try to think of what that means here, like fun over x in unif, that doesn't really make sense for fun, does it? Like I would know what that means. So yeah, this one simply does not work with this translation above. Okay, so let's change the translation. Actually, probably we don't want to solve this problem for every single big op separately, right? Like maybe we're missing an abstraction here that can generalize the problem. And I guess the abstraction in this case is like a set builder notation, right? Like what we actually want to say is something like, yeah, just do the union over all b such that are using set builder notation. Like that's the most simplest definition of the big union. And yeah, that actually seems to make all of that work. All right, yeah, this could feel a bit like cheating, of course. Like I've only postponed the problem now into the set builder notation. So I'll show you how that works in a second. But what I really want to emphasize here is again the generality that macros allow you to just like plug in the b on the left-hand side of the set builder notation here, which yeah, I think in many other systems would not make any sense, and it would basically be non-implementable. And that's really what yeah, if you think if you support Lisp-like macros, what that allows you to do. And of course, you don't really have to know what Lisp-like macros means if it just does the thing you want it to do. Okay, so yeah, how is all of this implemented? And how is the set builder notation implemented? I'll start with what this notation actually means. I already said it's a macro, like a command level macro. It's not on the term level, but on the top level, on the command level. And this actually expands into two new commands, a syntax command and a macro command. And yeah, so I think the syntax command is quite straightforward. It says, if I have a union, big union symbol, followed by a term, followed by a comma, followed by a term, that is now a new term, like a new syntax in the category, in the syntactic category term. And what can I do with that? Yeah, I can write a macro for that after this. So I can say, whenever you see the syntax with like B and R being placeholders or anti-quotations, then just translate that to the right-hand side, to the function, to the actual union, call to the actual union function using the set builder notation. Yeah, so you may know these quotations from Mean3. They basically look the same. They're syntax quotations of syntax trees. We just changed the anti-quotation syntax, which was quite silly in Mean3, and now just use $, if you're confused by that. But yeah, other than that, that doesn't look quite different from the notation, does it? It's just a bit more explicit, and we can probably guess more general, because now we are actually saying that we're parsing terms here, and so probably we can actually parse something else here if we want to. So yeah, that's just the implementation of the notation. Yeah, the semantics are unchanged. It does exactly the same thing down here.
How is term different from expression?
That's a good question in general, I guess. So in general, I think the terms are exactly interchangeable, and yeah.
But it's, I mean, you could have different. One is on the syntactic level, and the expressions are actually.
Yeah, that's exactly how it is right now. Like we have an inductive type expr, but we have a parser term. Yeah, and I don't know if that's a sensible distinction, but yeah, I guess now we at least have two different words for it. So yeah.
Can you also say something about the parser? Is it so fat parser?
Oh right, yeah, it's a bread parser, and so the big difference between that and Lean3 is that it is backtracking, and you can what's the word? Yeah, look forward into the stream if you want to, and if you have multiple notations, they can actually overlap. Like I could define a different union syntax here, something like that, and the Lean4 parser will simply try to parse the longest one, and that will win. Oh, I guess that doesn't actually work. Expected comma or exclamation mark. That's an exclamation mark. Okay, not sure, sorry. But at least it doesn't immediately destroy the other notation.
Is there a
I should try that.
Might lead to just performance? I guess users could do some.
Yeah, we have a theoretical concern. I think our current design is to just wait and see if it actually gets a practical concern. And what you can do is to just implement caching, like say, oh, at this position, I've already parsed the term in another branch. So yeah, I know what the result of that will be and just reuse that. Yeah, it's related a bit to, there's the packrad parser algorithm, which yeah, is basically doing this.
So we could now actually write down, we could define our own syntactic class like term 3 and define.
Yes, that's the next step. Oh, well, not quite. But I got to that. Okay, what did I actually want to show? All right, so I think now we've understood what notation means in terms of defining a syntax and defining its semantics using a macro. And now maybe we can actually, where's the stuff? Understand the set builder notation. Because what does it do? Well, it's a syntax declaration. That's easy, right? It's just phrases surrounding a term, followed by a type, followed by a term. And that's a new term. Okay, that's simple. And then the macro is actually a bit more interesting because now we have multiple different syntax translation rules. So it says, like, goes from top to bottom. It says that whenever you see this syntax, like a set builder with an element sign on the left-hand side and yeah, some placeholders in the other parts, then translate that to this right-hand side, which says like it's the set of all x so that x is in S and P holds, and P can still use x if it wants to. And we can of course do the same with less equals, and so on. And we could do some more freaky things on the right-hand side. I'm sure you'll come up with examples for that. I don't know. But yeah, if it's not any of these special forms, then as a default, we just plug it into function, into fun as before. And so that will work with, like, if it's a single variable or parentheses x colon type, then it will use the third equation here. Yeah. Right, so what you probably want to do, so this will not work right now, I guess, but you probably want to say something like, this are actually many terms, at least one actually. Yeah, that, okay, yeah, I'd probably have to import something. Yeah, you change the syntax to say, okay, here can be many terms, and then you change the macro to, I don't know, iteratively, recursively process them. Yeah, so that's not quite as simple, but definitely doable.
Between on the line syntax,
yeah,
is a term a parser?
Yes, exactly. So it's basically it's parsing different parts with like maximum precedence, and all of these are simply parsers. And yeah, if it's just seeing a string, then that is the parser for the symbol. Yeah. Yeah.
So in main3, there's a somewhat dubious feature where something like x and a, e or whatever, then there's actually a variable called capital H. It's found like.
Yeah. Yeah. Right.
Is this a ID? Is it possible to put that? Do that?
Like, do you actually want to access the H?
Yeah, well, sometimes you actually, they can make use of it in P.
Right. That works? I never tried that. Wow. Wow. Okay. Yeah, right. I completely forgot to say that, yeah, how this all worked in the free is like a complete hack. Like if we go back to the initial example, something like this, yeah, I'm not even sure if that's, most of you are aware of that. So how this was processed in the free is it does a union over all x, and then it does, as Reed said, a union over all the proofs that x is in unif. And it turns out that this double union actually is exactly the meaning that, that we want it to be. So okay, now you want to actually make use of that hack. Yeah. Right. So you're actually right in that this is unhygienic. Like if the name of the implementation spilled out into your user code, that would be unhygienic. Well, the good thing is that Lean4 allows you to be unhygienic if you really want to. I'm not sure if we could come up with a nicer syntax for that, like maybe, I don't know, h colon x in unif. I don't know. But yeah, if you really want to, you should be able to implement that, but maybe we could even come up with an even nicer solution.
Well, so what about pretty printing? So the macros will expand.
Right.
Is there any hope of going the other way?
It's a good topic. Interesting question. And I think I have a general solution for that, but definitely in the first version we go with a very simple approach that basically it will be able to pretty print like operators that just use I don't know, like infix operators. Like if you define your own plus or something, it will be able to pretty print that, but it may not be able to pretty print that. Yeah. But yeah, this is definitely something that could be improved in the future, and I have some ideas for that. All right. So what else was there? Okay, so this is how the set builder works. And I'm not sure. Are you satisfied with that? I mean, Reed already tried to improve on it. So there's one restriction here is still that the left-hand side of the set builder has to be a well-formed term. Like this was, fortunately, in all the examples so far, it just worked out. Like even x:t can be a valid term. That's a term type annotation as well as a binder. But yeah, maybe you want to do something more crazy. And just as a simple example, I'm not sure if that's, I don't know, maybe you want to get rid of these parentheses. I don't know. Do they annoy you? So yeah, this does not work with this implementation because x:something is not a valid term by itself without the parentheses. So if we want to do something like that, we really have to go out of the term syntactic category. And for that, I think I'll have to switch back to the slides because this is something we almost got working for today, but not quite. So I just go through the slides, which up to that gave exactly the same code as I did in the demo, and now here's the interesting part. All right, so let's say we want to get rid of the parentheses here in the second check. So yeah, I said that's not a valid term anymore. So what is it? Well, I don't know, let's just call it set index. So in the upper syntax, I now have used the set index parser in the second position. And what is a set index? Well, it's a completely new thing. I'll introduce in the lower part. I say it's a new syntactic category. Like I declare a syntactic category set index. And of course, this declare syntactic category keyword, that's just another macro for another meta program below. So what is a syntactic category? It's just something that can have one or more syntax declarations. So what is a set index? We have one syntax declaration. Any term is a set index. That's good for it. So all of our examples so far will work. And then we add the new thing. We say that any identifier followed by a colon followed by a term is also a set index. That's the new syntax we want to support. All right. Then, of course, we'll change the syntax of the set builder notation as well to use set index. And then the macro changes. But yeah, it's purely additive. We don't have to change the old translation rules. We just add, as the third equation here, a new rule that says, if you ever see a set builder using x:t, then just replace it with the basic fun, but with the parentheses, how fun expects it. And that actually just works. And yeah, so that's just to demonstrate that with macros, you are not bound anymore like you with notation to terms. You can introduce your very own syntax that looks nothing like existing terms. Yeah?
In the first derivation for the syntax of set index, why do you need a term there and not an identifier?
You mean in the second, the ident::colon term?
In the first syntax rule, when you say a set index can be a lone term, so I assume that's just for when you list one identifier alone. But what else does it accept then?
All the other parts, like if you write x in S, we want that to be a set index, and that is a valid term. So that will use the first syntax declaration.
With the membership.
Yeah.
Right. Okay.
Yeah, that's a valid term, so that works.
So you can add, at any time, you can add more macros to extend this?
You mean the existing set builder notation?
Yeah.
Yes, I guess you would really like to. Yeah, I think we should support this. Like the basic macro probably will not support it, but of course we can always build something more interesting using like it registers a new attribute, and you can then use that attribute to basically add new equations to an existing macro. Like that could be something like an extensible macro.
Instead of x, subset of y.
Yeah, it would be great if that is just extensible at any point. Yeah, but I think that will be will look slightly different. Like this is the basic usage. Okay. Was there anything else I wanted to say about this one? Yeah, I think that's fine. Yeah, like I really just wanted to show again the power that you have with a general macro system that does not bind you to just talking about terms or just talking about simple binding structures. And yeah, also to show you that at least parts of this are actually working. Like we do have something, it's not just code on slides, but there's an actual implementation behind that does interesting things already. Yeah.
But beyond implementation and slides, are you also writing documentation about it? Or is it the documentation?
So let's say right now we're really trying to do a good job documenting the implementation itself. So like that we understand it ourselves after half a year or something. But yeah, the user-facing documentation definitely still has to be written. Yes. And
Some mathematician will come in and say, we need the documentation and write it for us. So someone named Patrick, for example.
right. Yeah. I think so much about macros. That was mostly it from me. I don't have a conclusion slide this time because frankly, our work is not concluded yet. I would say the same thing as last year, which I don't remember. Instead, I did decide to resurface this one slide from last year simply because I was asked about this a few times already, which of course makes sense. Like, yeah, how do you imagine porting Lean 3 code to Lean 4 to work? And yeah, so this is definitely my very own personal opinion, but there's basically no change from last year. I do think that while we now actually have even more syntax changes, they are still mostly superficial, right? So yeah, if we write the Lean 3 syntax as Lean 4 syntax declarations and just use that to compile your Lean 3 code in Lean 4, then you can immediately work on it, work on fixing the other parts. And then like as a final step, we could just unfold these macros implementing the Lean 3 syntax so that now all of a sudden your whole file is written in Lean 4 syntax. That should just work. And in fact, we now have like something like a plugin system, like you can pass -- plugin to Lean, and it will load a dynamic library compiled from other Lean code and use that to basically modify the running Lean system. So that would be the thing that, for example, could inject the Lean 3 parsers so that you don't even have to change the mathlib source code to make use of them. So yeah, just as a rough idea, how could imagine that to work out. Yeah, what else is there? Probably there will be some minor changes in the elaborator. Like mostly it's just much more general and much more powerful than in Lean 3. But yeah, if you have a weird unification going on, maybe it will just break in Lean 4 and you'll have to slightly edit your code. But I don't see that to happen all that often. So that will be a manual thing, but I don't think that will be an issue. And then finally, of course, what also changes is the library. Like, yes, okay, we did rename everything. And at least in the first version, like public version of Lean 4, that you can actually download from a GitHub release, there definitely will be many things missing from Lean 3 and things that we do want to get back. And yeah, these simply will need to be re-implemented. But yeah, I guess, well, just tactics, like not every tactic you have in Lean 3 will immediately be there in Lean 4. But I think you can expect the first version to at least have simp. Like Yeah, but for example, maybe the SMT will not be there. And maybe it will never come back in this form because I think Leo has some other plans for that. Yeah. Right, so this will need to be implemented, but I guess depending on what exactly it is, this can also happen in MathLib. Like that is the beauty of Lean 4, that you can implement something yourself if it really is missing. Yeah, and I guess that was it for me. And I think we can smoothly move into the discussion format. Yeah, okay, thanks.
Have at 'em.
Yeah.
Sebastian, I'll let you field the questions, if that's okay.
Yeah, but yeah, I mean, doesn't even have to be questions. I think you can just like, yeah.
You showed that the compiler has some part of the code. Is the goal to rewrite the compiler entirely using and maybe thinking about it, or it's just like a few lines of code and it's going to stay C++?
Right. So yes. So I think the reason that the compiler is not completely clean yet is that yes, there were some APIs that it is using that were not yet available in Lean, and I believe the ultimate goal is definitely to rewrite it completely in Lean.
Oh, the compiler will be 100%. The green is going up.
Yeah. I think there's nothing at least stopping us from that. But that does not mean that it will be in a format that's like amenable to formal verification. So yeah, that's not a primary goal, to make it easy to formalize. Yeah. Maybe you can like take a part of it and formalize it, or slightly, I don't know, refactor it and formalize it. Then, yeah, that definitely will be easier if it's actually written in Lean. Yeah, Gabriel.
So, I mean, looking through the Lean source code, instead of decidable E, I've seen lots of has E.
Right. That's a good question. I'm not sure I have the full picture for this one. So I think it was mostly about like the additional overhead of talking about propositions and then coercing them into Boole when it's just about programming. Like, yeah, maybe if you like add together two Booleans, you really want to have a Boolean operator doing that. And there was some more discussion about this, but I'm not sure I can completely recall right now. Simon, do you recall anything in that regard?
With that?
Like basically the has be eq versus decidable, where we're going with bool versus prop.
What we were doing is that basically for some inequalities, they're not exactly the same as propositional equalities. Like when you compare expressions, you want alpha equivalent and not actual.
Right. Yes. Right. So, that's a good point. Yes.
That's one reason to keep them separate. But then there might be some coercion from one to the other, or some subclassing from one to the other. So, yeah, I don't know where it's going to go. Right now, it has the benefit that we don't have to write the proof of equality inside of our equality implementation.
Yeah, that too. Yeah.
Without practice, that would be kind of cumbersome.
So yeah, I think it's mostly about like having different views of equality, like the programmer view and the prover view, and actually expressing these as different operations. But yeah, I'm not exactly sure how they will merge again or what the interplay will be there. Yeah, Patrick?
About the tactic framework, do you still have plans to cache more of the tactic state when we have big proofs?
Right, right.
And we're going,
Yes, yes. I think we definitely want to have something like that. We have not really planned we haven't done any planning on that in, say, the last year, because we're just not there yet for the tactic framework. At least it will get much easier to implement in Lean than in Lean 3, because, well, now that everything is implemented in Lean, it is all, it's a purely functional language. It is all deterministic and reproducible, and that will make things much easier to implement regarding caching.
So this is a tactic language system has a syntactic category?
Yes, yes, something like that, exactly. Yeah.
So you can write down just the macros to parse the tactic.
Yeah, probably. Yeah, it's a good question how that will look like exactly, but yeah, definitely in Lean 4, you would only be able to like add new tactic names like in Lean 3, and after that can parse your own thing. You can just like introduce arbitrary new syntax inside begin end if you want to. Yeah.
Will they speculate in ordinary usage?
When that will make sense? Was that a question? Right. So, yeah, so I can probably say that considering our progress so far, we should have like a very first, okay, let's say alpha release of Lean 4 by, let's say, this summer. Like something that you can actually play with and experiment with, that probably will have tactics and will have a basic form of the language server so that you can actually use it outside of Emacs. And yeah, maybe, I don't know if it will be ready yet to like consider porting mathlib, but it should be ready to, yeah, for experimentation.
Are they going to be fancy, inductive, recursive, mutual messages?
I think Simon actually knows more about that than me, right? So
That won't be done by then.
yeah, probably not exactly. Yeah, so what I can say, you may already know that at least mutual inductors are now in the kernel, so they simply work out of the box how you would expect them to work. And yeah, this does include nested inductives. But yeah, the more fancy things, at least they're not there right now.
It will be much bigger.
Yeah.
So I haven't measured how much that was, but so that's basically the biggest change. And I don't think it made it that big, much bigger.
I think the expression syntax is quite different now. We don't have matters, but they are different.
Right, yeah, I'd say that's a minor change. Like, yes, the inductive type changed, but more or less it's still the same. Especially for the kernel.
Is it still consistent?
I'd hope so, yes. I don't think anyone's proved that so far, but yeah. Is it so much stuff? I mean, it's just a single feature. It definitely was a complete mess to do that, like in user space, outside of the kernel. Like the implementation was super complicated, and basically no one in the team understood it anymore. So that's a good reason to throw away code. And I think it's definitely simpler in the kernel, even if it makes the kernel itself bigger. And yeah, there are also, I'm not sure if there are any like reduction rules that now hold that did not before, but yeah, it does get clearer if you put at least this specific thing into the kernel. Yeah, Rob?
Yeah, so I know you kind of brushed by it at the end.
Yeah.
But I was wondering if you could say anything more about changes to the elaborator.
Right.
Because this seems like potentially the biggest danger of reporting that.
Yeah.
You say it's probably not too drastic.
So I'm not aware of any breaking change right now, like off the top of my head, I think. Like the biggest change to the elaborator itself, to the design, is the suspension of elaborating subterms to wait until more type information is available, so that, for example, the parameter, the argument order of a function call does not matter so much anymore, or should not matter at all. But I mean, yeah, that should be strictly more general, really. So yeah, I don't know. I don't see anything breaking there yet, but I'm sure there will be some edge case that will completely break.
Leo came up with an example that used to work in 3, but no longer worked with his version of
Right.
But
Yeah.
it was kind of convoluted. Do you remember the example in question?
Yeah. Was that the one he actually fixed after that? I'm not sure. I'd have to look it up.
He wasn't sure if it was a bug or a feature.
Yeah.
I don't know if he wanted to fix it.
Right. Yeah, that's how it usually goes if you change such a complex system. But yeah, I don't think
this is why I'm worried, right? Because even if it is in principle, strictly more general, it was like little edge cases could actually probably do show up in a big library.
Yeah, I'm sure we'll find some, but yeah, I don't know. I think this may as well have had broken if someone, if we have had still updated Lean 3, like in the past we had many such breakages.
Of course.
Yeah. Yeah, I don't have any hard data on that. Yeah.
The syntax is bound to attributes, right?
You mean the parsers, or?
Yeah, so
Yes.
Is it would it be possible that you activate syntax locally for a setup syntax to say, yeah, in this theory I want to work in number theory, or I want to work in measure theory, and you have certain
Right. Yeah, absolutely. I think I had that in last year's talk, that we really want to use what they called scope attributes that you can actually open in a scope, and that should include parser attributes. So we haven't. This has not been implemented yet, so I haven't included it in this talk. There's nothing new to say there, but yeah, this is definitely the plan. Like, you should be able to activate a set of parsers that are specific to your problem, and even deactivate a built-in parser from the standard lib and replace it with your own thing. Yeah, and of course you can always write a simple command macro that just does preparation steps, just execute some commands and call that wherever you need it.
Question about the pretty printer. Do you want to make it much more customizable? Or because, I mean, as mathematicians, we would like to define, when we define a concept or a function in Lean, we would want to include a kind of how it should be rendered by LaTeX and or things like that, so that maybe even the tactic state could be rendered by MATLAB inside.
Oh, I see.
Like that.
Yeah.
Is it something that could be feasible?
So it's not completely clear to me if you want a really completely different output format, if that actually should be part of the same pretty printer, or if you should are basically rewriting your own pretty printer with that. Like the task of the standard pretty printer in Lean should be to produce something that at least that as closely as possible resembles actual Lean code. I feel like if you want to go into a completely different format, you just should write your own system, your own pretty printer, which doesn't have to be that complicated, and probably you can reuse some parts, implementation parts of the other pretty printer.
think that it would be easier in Lean 4 to do also than in Lean 3. The part of the Ready printer is to convert a kernel expression into syntax, and then you render that syntax. So, for example, you would do operator. Lean 4 would do operator lookup for you, and it would convert all the function application into proper notation. And then if you have a specific way to render that notation, you can have a conversion from syntax to late that row, whatever you want to add with the syntax added. So it wouldn't be a pure kernel term that we would be rendering. Does that make sense? So part of the challenge in writing your own Ready printer for LaTeX, for example, is that you have you start with the kernel term, and in there you have function application, you have quantification, but you don't have the infix operators. You don't have all the fancy notation, which if we convert to syntax before doing the Ready printing, you would have that information. You would have information about what kind of syntax gave rise to that expression. Maybe not in a perfect way, but much better than having to re-implement it yourself every time.
Yeah, I think that's a good solution. Like, you don't actually want to replace the pretty printer, you just want to post-process the pretty printer output, and that should be very well possible.
Really, we want both, because one of the things that is currently frustrating in Lean is that sometimes if you just copy and paste what you see in the tactic state, it's no longer valid in code, and even the code.
Right.
And so clearly, we also want to be able to copy paste, but you can. It could be like currently, if you look at a web page where Majax is handling LaTeX, I mean, you can just right-click on some formula and get access to the text code that you can copy paste into your text file if you want. But it keeps both information.
Yeah.
The actual code and then the render.
This is more like a VS Code question, right? Not to render in VS Code.
No, because I mean, the VS Code needs to have the information.
Yeah,
it's not sufficient.
The last thing is now we get all this information, we need to implement it ourselves. So now we get what was he said, we get some information about the operator precedence and so on. Currently, in method, we do not get this information out of it. You cannot even run here. It would be very easy to do, and I think that's something method should provide to have like a vacant line.
One problem with Lean 3 is that the tactic state is just one string without any structure.
Right. Yeah, with Lean 4, you can definitely get like a concrete syntax tree out of the pretty printer, which like uses all the notations and so on, but it's an actual tree. And you can actually look into it and see what syntax is going on there.
It's kind of hard to do it perfectly, though, because when it's rendered, it doesn't show you the typecast instances, for example. And then you get it to Parse, and then the elaborator infers different typecast instances, so the whole type checking can fail because of that.
But that's not the only issue. And, I mean, that can be fixed by switching instances off.
Yeah. So there can be some either some hacks or some user introduction.
Yeah, pretty printing, like sound pretty printing is really hard if you have an actual elaborator in the other direction and want to print something that is still readable. Mario?
Every time that it prints, in all contexts, like printed in a way, then that is, especially if you wrote a parser extension, and you have some fancy syntax for generating a thing, you want to also be able to write converts and install it as an extension to the printer, so that, that you can get it.
Right. Yeah, I think that makes sense. Like, yeah, there should be an extension mechanism to the pretty printer to say, like, whenever you see an application of this function, like this actual constant, the full name, then just give that to the extension, and it will return a syntax tree that will then be integrated into the output. Yeah. So one issue with that is just with macros in general, is that if you have a notation like this, then that's fine. Okay, we can see if we see a call to union, we try to reverse that. But of course, this also depends on the argument to union being in exactly this form in the set builder notation. So now you're actually dependent on the other notation correctly refolding before you. And I don't know, that could get slightly tricky and or break very quickly. Yeah. So I'm not completely sure about that, but yeah, makes sense that we will have some extension system in the pretty printer. Yeah.
Sometimes my terms don't elaborate properly. I have to write an at and then about 10 underscores. Or maybe I have to write elab simple or elab. Is there changes to the elaborator? Is that still going to be?
Do we change anything about the lab simple? I'm not aware of any change right now. Yeah.
One thing relevant to that though is names of specific.
Oh yeah. I mean that's really convenient. Like if you have like one single argument that you have to give explicitly inside of 10 implicit arguments, you can't just write something like, oh yeah, I guess this will actually parse in the new. Well, somehow the screen turned off, so maybe I won't type it. But you can't just. Yeah. No. Anyway, yeah, you can have you have a syntax for named arguments in Mean4, so you can say give this specific implicit argument by name, parse this argument to this parameter. So you don't have to write 10 underscores anymore with the add. You just say this specific one, give it this value. Oh, yeah. Yes. This even for programming, this will be so useful that I'm very much looking forward to the point where we can just get rid of the old front end, completely delete it, and start really using the new syntax in the system itself. That will be very nice.
Is there a fun to change the naming scheme for the instances so that they can be used with named arguments more easily?
With the instance name?
Like, you don't name them explicitly, you put them in square brackets.
Oh, right.
They're called underscore
inst1. Yeah, that's probably not. That's a good question. I haven't thought about that yet. Yeah, I mean, of course you can give explicit names, but yeah, maybe that should be a nicer system for inferring them.
Maybe we could infer a name that starts with the letter of the class.
Yeah, or even just the class name itself. Like, yeah.
Okay, so we managed to fill the session out.
Right.
No problem. There will be time. There'll be lots of time today and tomorrow. I was going to ask him about the T-shirt. What? I was going to ask him about the T-shirt.
Yeah, sorry about that one.
This is presumably completely unrelatedly.
Yeah, I guess so. Can you read it?
Yeah. I can't read the last word, but it's.
All right. So, yeah. So, for those that can't see it or can't read German, it says.
With the name Lean, you will nearly.
Yeah, you're pretty damn close, basically. So I think this is the worst T-shirt I've ever owned, and I just found it in an online shop, and I had to buy it. And yeah, of course, it doesn't have anything to do with the peer improver. It's just someone went through a list of words and just generated that T-shirt for every one of them. But I was still wondering why is Lean exactly on this list. And so I looked at other T-shirts in this shop and quickly came became apparent that I usually have to do something with like a purple drink. And that was the day I learned that lean is also slang for some party truck. And that is probably why that word is in that table, in that database.
You see, there's references in the YouTube comments on my MSR.
Oh, wow. Yeah, no, I didn't know that before like a year ago or something.
So I'd like to close this session by saying something that we don't say often enough. So to Leo and to you and to everybody working on it, all of us we're enjoying Lean 3 very much. We're very grateful. We're very much looking forward. So thank you for this presentation. Thank you to Leo, and thank you to all of you for the hard work that we've done.
Thanks.
We'll take a usual half-hour coffee break and then come back up.